Okay, so in the session, we will be getting started with data structures. Data structures, in the previous labs, we have already completed lists using stacks using lists and queues. These parts have been done. We'll quickly get started with list comprehensions, and we'll try to cover up as much modules as we can cover in this session. Okay. So the first module we will be covering will be list comprehensions, which is very important concepts in Python programming. So what exactly is list comprehension? Let's have a quick understanding. List comprehensions provide a concise way to create lists. Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable, or to create a subsequence of those elements that satisfy a certain condition. So what are we going to have exactly? We are going to have list comprehensions are used in those applications where we have to make a new list of elements, and these elements will be the result of certain operation on some other iterable. Okay, so that is what we are going to do. So consider you have some list of squares available. So what do we have to do is we have to make it write in such a way that it is concise, and it should be a single line statement. That is something we need to cover up in list comprehensions. So what exactly we have to do is, suppose here we have a sample example where we have to create a list of squares. So in this case, what is happening on the first line of code, they have created a list named as squares. It is an empty list. Then for each element from 0 to 10, they have applied a square operation on it, and then they have appended the updated operation value into that list. And finally, the list has been printed. So you can see that this program is written in 4 different statements. What we can do is we can quickly convert it into a concise statement, and it could look something like this. Now here, what exactly happens? We do have a specific condition which we are applying, and after applying that condition, the result of this condition will be stored into some variable, and then that variable will be added as an element to the list. So this is something which we have to do. So what exactly is happening? So here is the code without list comprehension. What is happening over here? Let's say we have a list. We'll have a quick understanding of this code. Suppose you do have a quick list available. Now, what are you trying to do is, here we created a list. Let's say created a list. Now, after creating a list, we are going to perform some operation. Okay. Let's say perform operation on based on some condition, perform operation based on condition. Okay, so what exactly will happen? So we said, let's say for I in range of 10. Okay, so from 0 to 9, the iterable will be available. And what are we going to do? Let's say we are calculating a square. So the square will be, we will be calculating it using I into the range object. Okay, let's say this means the value raised to the power 2. So that is something like we are calculating the square. So this is performing operation, performing the operation, whatever operation we are performing. You can apply any operation as per your requirement, and then what we are doing is we are appending that result into a list. So let's say we have a list of squares. Now within that squares list, we are appending the value square. Okay, and finally what we are going to do, we are going to print the content of squares. Okay, so let's say if I run it, you can see that I'm going to get a result of squares for the values between 0 to 9. So I have got this result, but this can be quickly comprehended into a one single line of code. So how we can quickly modify it? Modify the code using list comprehension. So now what are we trying to do? Under the list comprehension, this is the general strategy of making a list comprehension. First, what we do have is we have an operation, we have a condition, okay, and we have an iterable. So first, you do need to have a iterable. On that iterable, based on some condition, you are going to perform an operation, and then the result of this will be stored onto a list. Something like this will happen. So what am I trying to do here is, I'm trying to make a list here. First, I will write the iterable. the very first thing when we define this, so first you create the iterable, second you create the condition in case if you want to specify any condition, or else you can leave the condition blank as well. And third is the operation, whatever operation you want to perform. Okay, now let's say, so currently I would like to write an iterable, let's say for I in range of 10. So this is my iterable, this is going to give me an iterable result. We will be iterating from 0 to 9. Now based on this condition, what we can based on this iterable, what we can do is we can apply some value on this, whatever the value is being returned here. So I can say, let's say I multiply by 2. So what am I doing here? I'm calculating the square of value available in I, and finally this is going to be stored within this list only. Okay, so if I say this is comprehended list, and if I print this comprehended list, so you will be able to see that both the lists are same, this one and the upper one. So what we can do is, with list comprehensions, we can avoid the code, we can quickly convert the code into one single line of code, and we can get the results printed in this specific way. Okay, now we'll do one more condition with all the three entities available in the code. So what am I going to do? Let us say now this time I want to calculate the squares, but only for those where I is let's say greater than 5 or so. Okay, or only for those where it can be divided by 2, or if it is a prime number, we can calculate like if n mod 2, something like that. Only then we are going to, once the condition is satisfied, only then we are going to perform the operations on it. Okay, so let's see how we are going to do it. So this time we are going to write the iterable first for I in range of 10. Here is the first iterable we are trying to create. Now we can quickly put in a specific condition over here. You can put in lambda conditions, or any other different conditions are also possible. You can define a number of conditions in it, and I'll give you certain examples of conditions here. Let's say we have specified here for range in X, for range in specific value. चलो यहाँ पे condition नहीं है, but मैं यहाँ पे define कर देता हूँ. If let's say I'll say ठीक है, if the value is I mod 2, like that. Okay, only for those values I'm going to perform or calculate the squares or something like that. Okay, so now this time you can see only those values where I'm going to get the I mod 2 something is not true. Let's say I have to calculate it as equal to 0. Okay, equal to 0, something like that. So I've made up a condition here. So this time I have got it for 0, 2, 4, 6, 8 and all that, for only those values between 0 to 1. So what do we do here? First, we have created an iterable object. Once we have iterated each element, we have checked the condition on that iterable item, and followed by that, whatever result we have got, we have put that result onto an operation, and the result of that operation, we have stored it onto a list. So this is an example 2 of list comprehension. 2 of list comprehension. So guys, I believe this is clear. Arush, that's clear to you?
Yes, sir.
Great. Now, similarly, we can write nested list comprehensions wherein we can have multiple lists in a list. Okay, that is also possible. So what does it say is the initial expression in a list comprehension can be an arbitrary expression, including another list comprehension. So consider the following example of a 3x4 matrix implemented as a list of 3 lists of length 4. Okay, so we do have a matrix here. We have one list, second list, and third list. So there are 3 lists within this list. So we call this as nested list. Now what we can do here is we can explore one iterable. Let's say for I in range of 4, this is the first iterable. Whatever value we are going to get, we are going to put that value here. Now here what is happening, we are actually calculating for row in that matrix. This is the second iterable working. Now for every row, we are going to put the value, and we can use both of these values in order to perform the operation, and we can make a list out of it. Okay, so here there is I1, this is the I2, and the operation is being performed over both the I-triples, and we get the final result. So somewhat like this, we can quickly have the nested list comprehensions also. So let us just make a matrix using nested list comprehensions. This matrix is very important, as most of the time it is used in machine learning, where you can have any problem, you can quickly convert the problem into a matrix and you can solve the problems. Okay, so problems, I mean the IT related problems, all these problems can be represented into a matrix, a 2-dimensional matrix or a 3-dimensional matrix, and then various algorithms of machine learning, deep learning, neural networks can be applied, and we can predict the results. Now, so you're going to make a matrix using the nested list comprehension. So here what we have is, first we have an iterable for I in range of 10, let's say. So first we are going to explore from all these values from 0 to 9. Now, what I want to do is, I want to write another iterable. Now this another iterable is going to loop up with respect to समथिंग लाइक वॉट एवर मैट्रिक्स इज अवेलेबल. ठीक है, ऊपर जो एक मैट्रिक्स दी हुई है उसके साथ उसका एक एक एलिमेंट को निकाल रहा है वो, एंड इंफॉर्मेशन एक्सट्रैक्ट कर रहा है. ठीक है, सो व्हाट विल डू इज, लेट अस जस्ट मेक दिस मैट्रिक्स आल्सो. I'll quickly, okay, so we do need to make a matrix here first. Let's say एक मैट्रिक्स बनाते हैं. मान लो हमारे पास एक स्पेसिफिक मैट्रिक्स है जिसमें फर्स्ट में हमारे पास 1, 2, 3, 4 है. सेकेंड रो कॉलम में हमारे पास 5, 6, 7, 8 है, और उसके बाद में हमारे पास 9, 10, 11, 12, something like this. So we do have a matrix available over here. Now what am I going to do from this matrix iterable? What I'll do is item in matrix. Okay, I'm reading for each item or for each row in matrix, let's say, because you need to read up each row. So we are reading each row. First we are going to get this element, second we are going to get this element, then third we are going to get this. So out of each of these, based on its index, we are going to fetch its value out. Okay, so what are we going to do? We're going to take this variable row and we are going to get the index element out. Okay, so we are going to get those values printed, and let's say I'll put something like 10, 20, 30, 40, so that the indexes and values are different. Okay, and it is observable. So I'll put it 50, 60, 70, 80, 120, 110, 190. Okay, so now we are going to make a matrix out of it. So that's how you can see we got one list, which is the bigger list. Now out of that bigger list, we have converted, we have made a iterable, we have read all that information. Now within that list, we are going to create second list also. And these lists will be internal lists, and these will be for each row. So first we are going to get the first row read. We are going to put up all those elements, and we are going to put the elements 10, 20, 30, 40, or whatever it is in the child list within the nested list format. Okay, so here what have I missed? So name matrix is not defined. Okay, here it is, matrix. Let's run it. So now once I run it, second it says list index out of range. Okay, I'm doing it something like 10. We have only 4 elements for we have only 0 to 3, 0, 1, 2, 3. Okay, 0, 1, 2, 3. For each element we'll be reading up. So let's say we'll take up to 4 only. So now we are going to test it. So now what happened? So first we have ranged from 0 to 3. We have got the rows read, and we have got the first element in first case. For index number 0, we extracted all the elements from index number 0, then all the elements from index number 1, then all the elements from index number 2, and then finally all the elements from index number 3. So that's how we extracted, and we have created lists within the lists. Okay, so this is something known as nested list comprehension concept. So we can use it whenever we do need to create issues like this. Okay, Next, what do we have is, we do have the delete statements in Python. So what does delete statements do? This is a way to remove an item from a list given its index instead of its value. So you can provide the index value and you can remove that element out. This process differs from the pop method because pop returns you the value. So whenever you pop an item from a list, you have always seen that it returns you a value, but delete does not return you a value and it completely removes the item out of the memory. Okay, so what are we going to do? Let us just quickly call delete, and let's say I have what I'll do is, let me just quickly make a list. Okay, so my sample, in the sample I have a few names. Let's say Devanshu, I have Arush, I have some Ajay, Vijay. Okay, so I've got a few names. Now what am I going to do? I'm going to call delete. So you can quickly call delete, you can take sample and you can provide the index. Let's say I want to delete an item at index number 1. And then I'm going to print the sample out. So whenever you want to delete an item from the list or from any dictionary as well, we can quickly delete it. So delete is a reserved keyword, and you can use this reserved delete keyword to delete items from any of the data structures like list, queues, stacks, tuples, sequences, and dictionaries. All these data structures can have their values removed using the delete statement. Now we'll proceed further. There are various other ways to delete. You can delete the slice also. You can delete the complete items within that list, right from index number 0 to 1 if you want to delete the complete list out. So we have that option available. Followed by, now we are going to have a discussion on tuples and sequences. Okay, let's come here. Let's just start with tuples and sequences. Okay, what are we having in tuples and sequences? Let's say, so we saw that lists and strings have many common properties such as indexing and slicing operations. So you are already comfortable with the indexing, I believe. You know how the positive and negative indexes both work. You have also done a lot of stuff on slicing also. So we have done slicing with all the positive indexes, the negative indexes, and the possible combinations of positive and negative, negatives and positives. So we have already done all that previously. Now what we are going to do, we are going to understand tuples and sequences here. Okay, so there are two examples of sequence data types available over here. So we do have list, we do have tuples, and we do have ranges. So in Python, how we use the tuple. So tuple is another sequence data type. The only property we do have in tuple is it is immutable. You cannot change the value once it is loaded onto a tuple. To create a tuple, we make use of round braces. And once you create a tuple with round braces, you cannot update the element once it is stored into the memory. And we have already discussed about tuples previously in the previous sequence. We have seen the memory stuff and all, but just for the sake of completion, I'll quickly take up. So let's say I'm going to create my tuple, and in the tuple, let's say you have a few names. Let's say Devanshu. Okay, I have Shukla. Let's say I have Arush. Then I have Patra. Let's say. Then I have, let's say, Shukla again, like that. So I've taken a few things. I'm just testing the immutability as well as the duplicacy of the elements. Okay, so I've created my tuple and I've quickly clicked on run. So you can see that in a tuple, we can have duplicates in it. It is not a set. Once we create a set, set removes all the duplicates out. But in a tuple, you can have duplicacies, but you cannot modify a value once it is stored onto a tuple. So suppose somehow I want to modify this Shukla out of here and I want to change it to Sharma, let's say. So what I'll do, I will try to go to my tuple and I will say at index number 1, I want to update this value to, let's say, Sharma, from Shukla to Sharma. But once I do it, it will say that, okay, sorry, my tuple assignment, let me run it, Sharma. So it will say, tuple object does not support item assignment. That means tuples are immutable. Okay, so you cannot remove the contents or elements once they have been added. You can delete it though, but you cannot modify the value. Okay. So if I say, if I want to delete this value somehow from my tuple, and I want to delete the index number 1, okay. So I will do that on the next, because I'm going to land up into the error. So I'll put it here. If I do delete that statement, now you can see that again, tuple does not support item deletion, which means once you have created the tuple, you won't be able to delete it as well. Okay. So as we have already told that it is an immutable stuff, you cannot modify the values once the tuple has been created. So it is created somewhat like a constant. Okay. So a constant variable, it could have only a single value, but if you want to have a collection of constants, then tuple could be a very good idea, because once created, you cannot move it, delete it, and so. Okay. So tuples cannot be deleted as well. Tuples cannot be deleted. Okay, like that. So we are done with both of these operations. How we can create tuples, and tuples are immutable. We cannot modify those values. Let us just proceed to the next topic in sequence. So we are done with understanding of tuples. Okay. We'll go here to the next step. We can create singletons as well. This is a pretty good way of observing. We have created a singleton here. You can quickly specify multiple trailing commas, and you can quickly paste it, and it creates a singleton for you. Now, this is already clear. And yes, multiple item assignments. Okay. Tuples support multiple item assignments. This is a very nice feature of Python. Okay. So suppose we have a tuple, and we have got, let's say we were writing some program and we got 3 responses out of tuple. Okay. Let's say I got a responses like, in the first response of a tuple, I've got a name. Okay. Devanshu. In the second, I've got, let's say, surname Shukla. In the third variable, I've got an age, let's say 30. And next, I've got a mobile number 965482537, something like that. Or let's say I've got a height. Okay. Let's say 5.9. Okay. Like this. So now what I can do is, I can quickly create 4 variables like this: name, comma, surname, comma, age, comma, height, and we can quickly store these values here. So now what happens in tuples give you this beautiful thing that you can quickly drag an information and save it to the respective variable. Okay. So this will be saved here. The 30th one will be saved in the age, and the last one, height, would be saved here. So we can quickly extract the information from tuples with respect to the index, and it can be stored onto the values. Okay. So I'm going to run it. Once I'm done with the run, I'll go to the next cell, and I'm going to print all the statements. I'll print name. I'll print the name here, followed by I'll print surname. I'm going to pass surname here. Then I'm going to print age. I'll put it somewhat like this, surname. I've put it age. I'll pass age. And finally, I'm going to put in height, and I'm going to pass the height. Okay. Now, once I run this, we got name, surname, age, and height. You can see that all these 4 values which have been assigned above with respect to the tuple, we can quickly access them. So in whenever we want to return multiple outputs, let's say, okay. So a lot of times it happens that whenever we are responding back in a result, we do have to provide multiple outputs. Let's say the return value has to be saved into 3 different variables. Let's say I don't want to keep it into a dictionary and again perform the JSON parsing operation. I just want to allot it in such a way that they should be stored into 3 values. Okay. So what do we do is, we can quickly make use of tuples in those cases, and it is quite effective. And there are a lot of examples, like when we create a axial graph in data science machine learning. Let's say if you want to make a plot, and if you want to make subplots in it, so there we do need to use tuples, wherein we can use different values and store on different variables, and then you can use accordingly. Okay. So this is a very important stuff of tuples, which is mostly used. Now what we'll do, we'll quickly proceed to the sets. Okay. Now here, what are we going to perform? We're going to perform sets operations on sets data structure. Okay. So what happens with set? So Python also include a data type for set. A set is an unordered collection with no duplicate elements. So this is the important idea. Okay. It's an unordered collection and it does not have duplicates. Whenever you land up into a condition that in your data you have got multiple duplicacies, and if you want to quickly remove those duplicacies out, what we do is we quickly save the elements or the data into a set, and it automatically removes the unwanted values out or the duplicate values out. So basic uses include membership testing and eliminating duplicate entries. These are the two main objectives of creating sets. Set objects are also supported by various set objects also support various mathematical operations like union of the data, intersection of the data, difference calculation, symmetric difference. So we can use it at various filter creation programs. Secondly, set uses curly braces just like dictionaries, and you can pass in a number of elements separated by commas, and you can have the set created with all the properties followed. Okay. Now, so how we are going to create the sets? So we create the sets using curly braces, and let's just call it as my set. And within this my set, let's say I'm going to again put up some name, Devanshu Shukla. Okay. Again, I'll put Devanshu. Okay. I'll put Arush, somewhat like this. So when we create the set, once we quickly print that content out, you can see that the duplicates elements will be removed, and we have only got Arush, Devanshu, and Shukla posted. Okay. And this list is an unordered list. Okay. So there is no specific order. It will automatically be stored with respect to your alphabetical order. Okay. So here you can see that earlier I inserted Arush at the end, but somehow Arush is coming at the first index, and that is because of the feature of unordered properties in sets, with which what it does, it sorts or arrange in an alphanumeric order, ascending order. Now, so that's how we make use of set statements. Similarly, to set list comprehensions, we also have set comprehensions also. And so what you can do is you can have an iterable, you can quickly check the conditions, and put it onto a variable, and then you can allot it to a set. So we do have the concepts of set comprehensions also in Python programming. Okay, so I'll type it over here. Python supports sets comprehension. Okay, and what it does in set comprehensions, let's quickly have a look. It follows the same strategy of creating the iterable, creating the condition, and performing the operation and putting the data onto the set. So now what I'll do is I'll make a comprehended set. Comprehended set. Within this comprehended set, what am I going to do? I'll write a quick iterable for I in range of 10, let's say. Okay, so here I've got an iterable. Now I'm going to quickly check up the lick again. Let's say if n mod 2 is equal to 0, that is whether the number is prime or not. So let's say I'll do it up to 100. So if the number is prime or not, then what am I going to do? I'm going to take that value I, and I'm going to multiply that with 10, let's say, and I'm going to put that value onto the set. And finally, I'm going to get the comprehended set printed. So once I run that, you can quickly observe, sorry, n is not defined. Sorry, this is I mod 2. So first we created this iterable, all the values one by one. Then we're going to check this I here in the condition. Okay. Once the condition is satisfied, then this I value will be stored here, and I into 10 operation will perform. Okay. Somewhat like this, the comprehension works. And I do have a very good stuff to show you. Let's say in case the way which I told you how that list comprehension works, I would quickly like to show you that program here. Let's say set comprehension. Okay, we have this set comprehension. I'll copy this for you and I'll just show you. how in the memory it works. Okay, so I've got this code written over here. I'll just debug this code. Okay, so now you can quickly observe how it works. So once I debug it, I'll get to the statement. So once we are processing this set information, you can quickly see first the range element has been identified here, which means the iterable condition. We get all those elements. Now all those elements have been identified. Now each iteration will be done for I in range, whatever it is. Okay, and then the comprehended set is going to perform, and we're going to get the appropriate outputs. Okay, so first this happens. You're going to grab the range, then you're going to check the conditions, and followed by you're going to perform the operation. So that is how things works here when it comes to the comprehended set. So let's run it. So once I run the comprehended set, now you can quickly see we are going to grab the values. So I'll just keep the values up to 10 only, just for the visibility purpose. So you can see that only the even numbers have been identified, and we got a set of this. Okay, like that. So similarly, you can define many such operations as per your interests and understanding. Okay. Now we'll go to the next step. So we have explored tuples, set, all the sequences. Dictionaries, you guys are already available. Let's just quickly go here for dictionaries. So dictionaries always is a key value pair. I have already always told you this. This is one of the topmost data structure we use, and why we use it, irrespective of the size, accessing the information, updating the information, deleting the information, or creating the information is big O of 1 in a dictionary. Okay, and this is one of the best data structures. Hence, in majority of the cases, dictionaries are used. Okay, so the time complexity of disk dictionary operations for crude create, read, update, delete is big O of 1, irrespective of the size of your data. Let's say you have 100 billion keys available within the dictionary, but still in one instruction set, you're going to get any of the keys filtered out from this dictionary. Okay, dictionaries are one of the topmost data structures used in majority of the programming. Okay, even we can perform multi user processing using dictionaries. Okay, so dictionaries are one of the topmost data structures which we always use, and it is the highly used data structure in majority of the programming languages. So how can we create a dictionary? Let's say I'll quickly go here. I'll create a my dictionary. Within my dictionary, I'm going to put it a key value, let's say name. Then I'm going to put it the value for it. Let's say Devanshu. Then I have specified age. Let's say the age would be 30. And now I'm going to print my dictionary, somewhat like this. I do my dict. Once I do my dict, you can quickly observe that we got the dictionary set created. Okay. Now, similarly, we do have all the operations of dictionaries available, which we can make use of. You can quickly delete from the dictionary. You can update the value. Let's say if I want to update the value of key of name. So what am I going to do? Let's say I'm going to change it to Sudhanshu. So that is completely possible. And I can quickly run my mydict, and you can see that since I have created the dictionary with the name Devanshu, but since I have modified it, since it is a mutable data structure, we have got an updated name Devanshu in the dictionary list. Similarly, if you want to delete something, let's say I want to delete my dictionary and I want to delete the age element out of it. And again, if I print my dictionary, so I'm going to create it, I'm going to update a name Devanshu in it, Sudhanshu in it, and then I'm going to delete the age key from the dictionary, and finally you can see that I'm going to only get name is Sudhanshu, like that. So that's how we do have the create operation. We do have the read operations also. So in order to perform the read operations, let's say if you want to quickly get, let's say print the value of name key in dictionary is, okay, so what am I going to do? I'm going to get my dictionary, my dict, and within this I'm going to pass my key name. The key name is name, suppose, so we are going to get its value return. So once you print it, you're going to get the value of name key in dictionary Simply, we can quickly create the dictionary and we can create, read, update, delete. All these 4 operations can be quickly performed. Okay. Now, so that's how we do a lot of stuff. Now, how do we loop in dictionaries? Because this is very, very important. Okay. Suppose we have some n number of items in a dictionary, but how are we going to loop it? How we are going to identify the index, and how can we print the key and value pairs of it? Okay, so that is what we are going to quickly perform. So suppose I've got my dictionary 1, and in my dictionary 1 I have something like okay, I'll just use my name and all this value. So let's say name is Devanshu. Again, I'm going to define it in this way. Let's say name, I'll put it all this values, age, height, okay, 5.9, like this. So I've got 3 values. Now what I want to do is I want to perform loops on dictionaries. Okay, so when we want to perform loop on dictionaries, what do? We can quickly write a for loop. Now here we have to need both. We need to get the index as well as we need to get the value. Okay, for index comma value in your my dictionary 1, that is how we can quickly grab, and then we can explore all the items. So once we call my dict 1 dot all the items, we are going to get an iterable returned, and it is going to print the index, and I'll say the index is, I'll print the value of index, followed by I'll say value is, and I'll print the value of value. Okay, तो अब जैसे ही हम इसको प्रिंट करेंगे, अब हमारे पास नेम, एज एंड हाइट, वो तीनों निकल के आ जाएंगे. So we are getting this message, index is name and value is Devanshu. So I'll just keep it small Devanshu, and I'm going to modify the message a little. I'll put it in a statement. So I'm going to get information somewhat like this. Index is name and value is Devanshu. Index is age and value is 30. Index is height and value is 5.9. So similarly, you can quickly perform a loop on a dictionary element, and you can quickly extract the elements out of it. So this is one of the nicest way with which we can quickly extract information. Okay. Now, so as well as, so this is one very nice things which we can. Now, when looping through a sequence, the position, index, and corresponding value can be retrieved at the same time using the enumerate function also. Okay, so there is a function enumerate. Let's say sometimes if you want to iterate a list structure, okay, and you don't have the indexes available by default. So what you can do is you can always call the enumerate function. Okay, enumerate function helps you return index and value associated to it, like that. Okay, so we can always do this. So let's say if we have a list, my list, okay, and I've got certain elements, let's say 10, 20, 30, 40, 50. Now you can see that we have not explicitly specified any indexes here on the list. We just know that on index number 0 we have 10, on index number 1 we have 20, and so on. But with the enumerate facility, what we can do is, so we can quickly write for index comma value in enumerate of your my list. So in case if you have a iterable which does not have an index, but you do want to grab the index, then what we can do is we can quickly get it through the enumerate function. So we can quickly print the index and value, and you're going to get the values printed. So we got the index printed as at index number 0, we have 10, at index number 1, we have 20, at index number 2, we have 30, and so on. Okay. So enumerate is also a very important function which is used for looping techniques, and we can extract the key value pairs accordingly from the data structure. Okay. Similarly, there is one more very nice function which we use to pair up. Okay. So this is to loop over 2 or more sequences at the same time. The entries can be paired with the zip function. Okay. So let's say we have 2 sequences and we want to loop over it. Okay. We do have the questions as well. We do have to crawl over the answers as well. So how do we match it, the same index on both of the lists? Okay. How can we do that? So we can quickly do that with the zip functionality. Okay. Zip is a very nice functionality wherein it can quickly join two iterables and you can quickly grab information from two lists. Okay. I'll show you some examples out of it. Suppose I have, let's say, we have a name of actors. Okay. Let's say we have Salman, okay, Ranveer, and Ranveer Kapoor. Okay, let's say. So we got these three names, and we got a few actresses as well. So let's say I've got Katrina. Okay, I've got Deepika, and I've got Alia. Okay, so now we have two lists, but somehow my objective is to print, let's say, uh, the opposite. We have to print it something like the opposite actress of Salman is Katrina. Somewhat like this I want to print it. Okay, so now what I will be doing, I cannot, instead of getting the index calling from both the lists, you can quickly zip it and do it in one go. Okay, we can quickly grab that information here. So now, so we can quickly do it like this. Let's say for actor comma actress in, we can quickly zip it and we'll say the list of actors and the list of actresses. Actress. Okay, so the elements of actors will get into actor, the elements from actresses, let's say, I'll quickly put it like this. So all the items from actresses will go into actress, and we are going to print, we are going to print the statement in an appropriate way. Okay, so we'll print opposite, let's say I said the opposite actress of actor name is actress. Okay, somewhat like this. So I printed that. Now you can see in one go, we are going to get the correct information printed out. So we don't need to get the index of one and then to get it from the other. You can quickly zip multiple iterables together and you can extract the information out. Okay. So this is something which is very nice, which is available with the standard looping techniques in Python, and other languages do not offer this facility, but yes, we do have these facilities available in Python programming. Now, the next point what we have is, let's say to loop over a sequence in reverse, first specify the sequence in a forward direction and then call the reversed function. Okay. So this is also very important. What people generally do is, there is a lot of time that they want to do the process in a reversed order. Okay. So what we can do is, in case this will be printed in the reverse order, like Ranveer Alia, Ranveer Deepika, and Salman Katrina. Something like this needs to be done. Okay. So what I'll do is, I can quickly traverse the list in a reversed order. Okay. So you quickly call the function reversed, and then you can zip it, and we can try that. Okay. So, okay, zip object is not reversible, not a problem. We'll do it with a single one. Let's say we are going to reverse only a single actors. Okay, एक single iterable कोई कर सकता है, ये zipped objects को नहीं कर पाता है. ठीक है, कोई problem नहीं, हमने actors कर दिया. And let's say we are going to print the name of the actor, and I'm going to remove the actress from here. Okay, but this time the names are going to be printed in reversed order. First we are going to get Ranveer, and then Salman. Okay, like that. So we got Ranveer, and Salman, because now the iterable has been printed in the reversed order. But we cannot apply that on the zip, so that also we got to understand. Okay. Now, so we're done with many of these techniques, how we can quickly do all that stuff. Allotment of 3 variables we have already seen. Okay. Conditions we already understand. Comparing the sequences is another important information which we can quickly see. That is also very nice in Python. Now we will quickly cover this part also. let's say comparing the sequences in Python. Okay, so suppose you have multiple sequences available over here. Okay, we do have this list. Let's say 1 2 3 is a tuple and 1 2 4 is a tuple. So we will get to understand that 1 2 4 is greater than the tuple 1 2 3. Okay, is that clear? So we do have lists. We can quickly compare the lists. We can quickly compare tuples with respect to the list. Okay, जो भी order priority में element है, चाहे एक में ज़्यादा हैं, दूसरे में कम हैं, तो भी हम उस sequence में we can quickly have a look. ठीक है, number of items के basis पे. These are some of the operations which we can actually perform in comparison of the sequences also. So that's pretty simple. इसके लिए क्या time waste करना है? We have already seen that we have multiple sequences available and we can apply techniques on it. Okay, so that's how these were the sections available. Structures part. So we are done with the complete sequence. We have covered these from list comprehensions up till comparing sequences and other types. We have covered the complete data structures module number 5. Now we'll go to the section 6 where we'll cover up the modules section and we'll see what all we do have available over here. Let's have a quick look. Now, so what are the modules in Python? Let's have a quick look. So if you quit from Python interpreter and enter it again, the definitions you have made are lost. Okay, so we do have whatever functions you will define, whatever variables you will define, it will be lost once you have closed your session. Therefore, if you want to write a somewhat longer program, you are better off using text editor to prepare the input for the interpreter and running it with the file as input instead. This is known as creating a script. Okay, so what are they saying? We can actually create Python scripts which can be runnable any time, and they can be programs which could be running for a longer duration, even if you want to close the actual program and so. Okay, and it might be running. There are various other techniques to do that, but we'll see what Python has to offer initially. So you may want to split it into several files for easier maintenance. You may also want to use a handy function that you have written in several programs without copying its definition into each program. So to support this, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called a module. Okay. So what you can do is you can define your functions and you can keep your functions saved in a module, and then these module definitions can be used and imported in other modules or into the main code. The collection of variables that you have access to in a script executed at the top level as well in the calculator mode, whatever is written over there. Now, next what it says, a module is a file containing Python definitions and statements. So what is a module? A module is a file which contains Python definitions, which means you can define the Python functions and you can have a number of statements within each Python function. The file name is the module name with the suffix .py appended. So within a module, the module's name as a string is available as the value of the global variable, that is __ name. So let's say if you want to call a specific module, you can call if __ name equal to the file name. So for instance, your favorite text editor to create a file called fibo.py in the current directory with the following contents. So what they are trying to do, they're creating a Fibonacci sequence where they are taking values a comma b. If a is less than nth value, it is going to update the value of b into a, and it is going to add value of a plus b and will store it into b. So that's a Fibonacci sequence 1 with which Fibonacci numbers can be printed. Second, there is another category. They have made a simple list. Now they got a, b stored. Now a less than n, they appended the list into a. And that is something, there are two functions where in one we are printing the value and in second we are returning a list like that, okay, of Fibonacci numbers. So now what we can do is you can quickly save that file as .py file, and then you can import it in any of the functions wherever you want to use it. And then you can put up a value and call that function, okay? Now, so we'll do that simply. How can we do that? Let's have let us do in a curated Jupyter notebook, And for this, I'll get to our Hack with Us platform. ठीक है, उस पे चलते हैं. hackwither.in/121. We will be creating modules here, and we'll see how modules are created. Now, so I'm going to go to the data structures lab. And within this, I do have a Jupyter notebook setup. मैं इस Jupyter notebook को use करूँगा. I'll create multiple files here on the same sequence, and then we are going to use those. Okay. So let it load. Yeah. So I've got this loaded, and let us do one thing. So we are going to create a new Python 3 file. Let's say I'm going to call this file as this is going to be my, let's say, Fibonacci.py. Okay, I'll call it as Fibonacci.py. Okay, Fibonacci.py. Now what we have to do is we just have to define a function over here. So let's say what I'm doing is मैं यहाँ पे एक Fibonacci sequence design कर रहा हूँ. ठीक है. So what exactly I want to do is, let's say I've got a value here. Sorry. So what I'll do is I'm going to take up two values, a comma b, and let's say I'll start from 0, 1. Now what the Fibonacci sequence, what does it says? It says you're going to loop through all the elements till its value is less than n, up to whatever number we have provided, and then we are going to print it accordingly, whatever is the number, and going to have that addition, and finally we are going to print the values out. Okay, somewhat like that. So that's what we are going to do now. So let's get here. So what we'll do, we'll quickly check. We got these two values. While a's value is less than n, and n is something which will be given to us by the program, by the calling program. So I'm going to print in the value of a. Okay, and you can actually show the new line operator also, or some additional statements. So what they use here is the end. What should be the end? So by default, end operator is /n, and here they are using the end operator as a space because they want to print multiple Fibonacci sequence one after other, or else we can use comma also. Okay, I'll use comma and a space. Now what next we are going to do? So we are going to put into the value of a comma b. So I'll save the value of b into a, and I'll save the value of a plus b into b. Something like this is going to happen. Okay, and finally we're going to print nothing. Okay, just like that, a simple pass statement. So we defined this statement. Okay, just for safety purpose, if you want to quickly check up, you can quickly do that check with calling this Fibonacci function below. Okay, I'll just test it. Let's say I'll test it with Fibonacci of 10, and if I call it, I get a value from 0 to 8, separate depending on the number of elements I'm doing. So I wanted to print Fibonacci numbers up to 100, so I'll quickly get the Fibonacci numbers like that. Okay, so what I'll do is I've just deleted this, and this is my module, and I've saved it as Fibonacci.py. Now what I'll do, I can quickly go to a new file. Okay, let me just create a new file now. I'll go to file, I'll create a new Python 3 notebook. I'll leave this page. Okay, what I'll do is, let me just save it as calling file. Okay, this is going to be my calling file, and I'll go to open first, and I'll show you that okay, this becomes the ipynb file. So I would really like to modify this. Okay, let me just edit it. Edit. It shouldn't save as an ipynb extension, but somehow it is saving as an ipy extension. So what I'll do is I'll just quickly download it in py format, and I'll save it, upload it again so that we can use it. Okay, just give me a moment. So the Jupyter notebook is loading. Okay, so I have this file. What I'll do is, let me just file save as. I'll download it as a py file. Okay, and I've got Fibonacci.py.py, somewhat like that. I'll just rename it once. I just want the py extension. So I've got Fibonacci.py. What I'll do is, I'll go to my previous code here, where I was writing on Collab. Okay. Now here on Collab, what I'm doing is I'm uploading one file, the Fibonacci.py file, Fibonacci.py. Once I've uploaded this file, okay, you can see that I've got Fibonacci.py file uploaded here. We can quickly import that file now. Import Fibonacci. Okay. You can quickly call import Fibonacci. And this Python file Fibonacci.py has now been uploaded here. And now what we can do is, with this Fibonacci, okay, what we can do is we can call the fib function and we can quickly print the Fibonacci sequence. So what you can do is you can define a Python module and you can quickly grab the kind of information. I just need to see, I think I need to quickly check the. So I've got A and B, I've got that file. I just have to print that out. So somehow that has gone into an infinite loop. Okay. While A is less than N and I've given the value 100 and I'm going to print that statement out. And finally, that's all. Save it. Okay, here the value is not adding. Somehow when I was copying it, missed that value. So I will put A comma B is equal to value of B will be saved into A and value of A plus B will be saved into this one. Okay. So I'll go to file and save. Is saving the notebook. So the save is successful. Now I would like to quickly import it again. So now that's loaded into the memory and I've called the Fibonacci fib sequence now. And you can see that we have got the result exported. Okay. So this is pretty simple. You can quickly create any of the file. You can define your methods simply in it and you can quickly import that. Okay. So that's how the import pandas, SPD and all that stuff, whatever we do, we can quickly do that. And we can also do it like we can create an object of this file. Okay. And instead of this complete Fibonacci, we can call fb.fib. Okay. So let's say I've created an object for it and then I can call fb.fib and I can get the same results. Okay. So we can quickly create any of the files written in Python and these are known as modules and modules are very, very important. Okay. So that's how we make use of the module structure. Okay. Now guys here, so you can see that you got a quick look into how modules work and how we can quickly make use of those modules. Now you can import multiple methods from modules also. Okay, let's say I'll quickly go here and I'll define more functions. So once when I have created the define, second I want to create an add module. Let's say I want to give A plus B also here. Okay, let's say I have defined another method A comma B and I want to return a result of A plus B. Okay, that's what I want to return also from here. So we have this facility that not just one, you can import both the modules. You can import Fibonacci or you can say like this: from Fibonacci, import ffib, which is the Fibonacci function, comma add, which is the add function. Okay, so we got fib and add added. I just need to save it. I've got another definition add. I think the file is not saved here. I'll just save it, Control S, just close it, and I'll quickly see if I can open it. And I've got the code updated. Yes, I've got the code updated. I've got another method. I've got and a comma b, and we have got an and method loaded over here. Okay, so वैसे तो कॉमा सेपरेटेड ही हमें डिफाइन करने होते हैं जितने भी n नंबर ऑफ मॉड्यूल्स आपको उसके अंदर इंपोर्ट करने हैं, बट समहाउ दैट कुड बी अ सेव सीक्वेंस इशू. ठीक है, now here I was here and you can see that we are doing from import. Sorry, let's save it. एक बार दोबारा सेव करता हूँ. somehow I think सेव नहीं हुआ होगा. From Fibonacci.py, I've done that save. I just want to run it again. Just saying import error. Cannot import name add from Fibonacci. Due to a missing package, you can manually install dependencies, either pip and all that. Let's say add some. I'll just change the name of it. Okay, so I just imported it with another name, but somehow it is not importing that, and I'm not sure why. I think it's not saving it. Maybe properly save नहीं हो रहा है ये content इसके ऊपर, I think. ठीक है, but चलो anyways, what we'll do is we'll discuss on it. Okay, discuss करेंगे आगे, या तो दोबारा बना सकते हैं, but the process is simple. What you can do is you can quickly import and you can call different methods, or else you can also do import star and it could be automatically imported and we can use it accordingly. Okay, so this is one way of loading the scripts and keeping it. And whenever you want to run a specific script, you can quickly import that file and execute the arguments and all. Okay, so modules are very important, and there are standard modules like we do have a directory function, we do have the system modules. Simple सी चीजें हैं. You can quickly call the specific directory function and you can see what all internal information we do have available for that particular property. We can get into that file structure and we can see all the standard input, standard output, and all the built-in module definitions. Okay, so you can quickly understand whenever you use a directory function, it is used to find out which names a module defines, and it returns a sorted list of strings. So we have all this property like standard input for that, standard output for that, and this totally depends upon the number of methods or functions, whatever is being defined. So now here, I'll quickly check back here. We will go to the collab file, and suppose I have these two files here, and what I'll do is I'll quickly get to this directory, dir, and I'm going to get that dir for fib. Okay, so once we do dir for fib, now you can see that sorry, we have to do it for Fibonacci. We do it for Fibonacci. So within this Fibonacci, we can see that it is only defining one method, fib. Somehow this has not been saved into this file. That is why it is not being displayed. So again, what we have to do is we have to write it on some other code editor, and then we have to upload the file and we'll be able to get the methods. So directory is one of the finest methods with which we can quickly get to have all the methods and every functions which is available in that. So suppose we make use of a lot of time we make use of, let's say, pandas. Okay, so we can quickly do a search on pandas and we can quickly filter out what all methods are defined within pandas and what all we can use. So for this, what we have to import pandas first. Let's import pandas, and then we can quickly have a dir on pandas. Okay, directory on pandas. So pandas you will be using, it's one of the most used data structure in machine learning. So it helps us create two-dimensional size mutable data structures. So it has all these functions available: Boolean data type, it has data frames, data offset, HD store, index, D types, multi-indexes, periods, everything. So you don't need to get into any doc. You can quickly check back what all functions methods have been defined within that, and we can use it. Okay. So this is a good way of accessing the modules and all the informations available within that. Okay, so make sure you make use of directory functions effectively so as to grab more and more information about the modules you're using. So that's something on modules, what we have actually understood. So in the similar way, we get the packages also, and we can quickly import all these modules from a specific package, and whatever functions you are defining, we can quickly use it. So this is something which we cover in modules and functions. So it's a pretty easy stuff. You just have to define a Python file, define all your function definitions, and all these function definitions can be used in any of the later codes. Okay, in new programs or new codes you are building in, or other programmers can also use your modules. Okay, and simply you can see that since Python is open source, whatever requests, whatever modules you import in your Python program, you can quickly see what all functions they have, as well as you can quickly check the directory of that module, and you can go to that directory and see the source code of how all these things have been implemented. So that could be a real eye opener in order to understand what all happens within within the module structure and everything. Okay, so that is something we have covered up to the modules part. Okay, in the next session, what all we'll do, we'll quickly cover the input output errors and the classes part, and that would be the complete knowledge stuff of fundamentals of Python. And then we'll be performing some standard library operations, and we'll proceed towards competitive programming problems. So that's all for the day, and we'll continue in the next session. So Arush, is that clear up till here?
Yes, sir.
Great, great, great. So I'll just share the video, and rest we'll catch up in the next session.
So can you please share the code as well?
Yeah, I'll share the code.
Okay. Thank you, sir. Thank you.
Take care. Bye-bye.